We're looking at uncertainty and sig figs in this PowerPoint. This is a recap, and so things that you should know. So the last digit of every measurement is an estimate and therefore uncertain. So if they're all measurements have uncertainty. So we know measurements are performed with instruments, and the instruments will have a limit to determining the number of decimal places they can make a measurement to, and plus there's something called user care. So pretty hard to see the numbers on here, so we won't worry about that. Accuracy, very simple, how close your measurements are to the actual value, the true value, or in some cases accepted value. Here precision is talking about the repeatability of measurements. Are the different measurements close to the actual value, in other words accurate, but also are they scattered? So here it's not accurate, it's not precise. They're not hitting the target and they're spread out. Here they're precise but not accurate, and here they're precise and accurate. But precision also has a meaning in terms of if you've measured something, okay, 215 grams plus or minus 0.5 grams. That plus or minus 0.5 grams is also telling us about the precision. We're not too worried about these types of errors, so we'll skip along to sig figs. We love it. All non-zero digits are significant, so any number other than 0 is significant. Zeros, you have to check. In this case, these are all leading zeros, they're just placeholders, so this one only has 3 sig figs. Captive zeros, I've called them embedded zeros, are always significant. So that 0 is embedded between 2 significant digits, so 4 sig figs. Trailing zeros, only if they're to the right decimal point, so this one has 4 sig figs. These are conversion factors, so infinite sig figs in that case. So if we look at that, you can try these, and hopefully you can recognize they're 5 sig figs. And hopefully you can look at that and get 4 sig figs. If you can't, you've got some work ahead of you. Now, I don't like the fact they put commas in here. That's not a good thing to do, but 1, 2, 3, 4, 5. These are embedded. This is a trailing placeholder. Avoid commas, just put in spaces in groups of 3. Here you only need to look at the stem to know it's 3 sig figs. And here it's going to be 2 sig figs. Here are those slimy commas again. And in this case, it's just going to have 2 sig figs. So multiplication division is limited by your least precise measurement in terms of number of sig figs. So here we're going to get an answer and we're going to chop it to 2 sig figs. Here we have 3 and 2. Calculator belches out this number, so we have to chop to 2. So the 6 rounds the 2 up to a 3. Here 4 sig figs, 3 sig figs. Calculator says this. And we're going to have to chop to 3, and the 9 is going to push the 1 up to a 2. Here we have 1 sig fig, here we have 4. And so the 7 is going to push the 4 up to a 5. Here we have 2 sig figs, here we have 2 sig figs. So now the 6 is going to push the 3 up to a 4, so it's 240, but it's best to write 2.4 times 10 squared. So this is a kind of sloppy way to do it. It does look like 2 sig figs. Scientific notation solves that. Strange units. This has actually come out in foot-pounds or pound-foots, and that's probably a unit of torque. Here we have 5 and 3, so we're going to chop our answer to 3. And again, sig figs is what we should worry about, but we should put it in scientific notation to make it clear. Here we have 3 sig figs, and there's 3 sig figs. And the 6 is going to push the 5 up to a 6. Addition, subtraction is all about the absolute place value. So when we look at this, we should actually line these up vertically. And we see, we know this is the nearest tenth, we know this is the nearest thousandth. And so we have to chop here at the nearest tenth, and the 3 rounds down. Here we know things hundredth, nearest tenth, so we're going to chop to the tenth, so it's going to be 10.2. Here we know the nearest tenth, hundredth, we're going to have to chop to the tenth, and the 7 pushes 2 up to a 3. Here we know it's the nearest hundredth, nearest thousandth, our answer we're going to have to chop the nearest hundredth, and the 1's going to round it down. Yes, you've got to have some rounding skills. Nearest tenth, nearest thousandth, our answer has to be chopped to the nearest tenth. And so we're going to get rid of the 2, 8, and the 2 at the end will stay. And here we know nearest tenth, nearest hundredth, our answer we're going to have to chop to the nearest tenth, and the 7 rounds the 5 up to a 6. And here we know it's the nearest thousandth. So our answer says that, but now we have to do something about this because that only is 100. We're going to stick on a 0. We have to keep it. We don't want to lose a sig fig. So hopefully that was somewhat helpful as we review sig figs and calculations.